presenters here shortly. On behalf of the New York, New Jersey Education or Occupational Safety and Health Center, the Southern California NIOSH Education and Research Center, and the Northern California Education and Research Center for Occupational and Environmental Health, it is our absolute pleasure to welcome you to today's session. We regularly host occupational and environmental health-related webinars and are really excited to have this opportunity to provide free continuing education credit to members of the American Institute of Architects and the International Design Continuing Education Council. We're really glad to have you here with us today and to discuss the role of architects and interior designers in protecting the health and safety of workers. At the end of today's session, you will receive a link to our evaluation form, and we'd love to hear from you regarding what other topics might be of interest. Today's webinar, Designing for Safety, Protecting Worker Health from the Hazards of Engineered Stone, will be presented by Kristin Cummings, MD, MPH, Michael Wilson, PhD, MPH, Lona Rerick, Lead Fellow, Well AP and LFA, and Kimberly Mickelburough. And a special thank you to Jonah Rosen from AIA St. Gross in Baltimore for helping provide some guidance in developing this webinar and helping us reach a new audience of interested learners. The CEU is registered with the Interior Design Continuing Education Council for continuing education credits, and this credit will be accepted by the American Society of Interior Designers, International Interior Designers Association, and Interior Designers of Canada. And if you are a member of IDCEC, please provide your unique IDCEC number because your attendance will be reported in the IDCEC system directly in lieu of a certificate of completion. And this activity was also approved by AIA. Few other housekeeping announcements before we get started today. You are going to be muted during the presentation. So if you'd like to answer a question, please enter it into the online Q&A box. And there will be a panel discussion following today's presentations, so will be plenty of time to answer your questions. We'll also have the chat open, so you can say hello to one another and join in on the conversation. And this presentation is being recorded and will be made available on the Center for Occupational and Environmental Health YouTube page within 5 business days. And all participants who logged in today, their registration email for the full presentation will receive an email to a link to the evaluation form that will qualify you for a certificate of completion with 1.5 continuing education contact hours. And again, if you're a member of IDCEC, please be sure that we have your unique IDCEC number so we can report you to the system in lieu of that certificate. Without further ado, it is my pleasure to hand it over to my co-moderators to introduce our first speaker for today.
Thank you, Michelle, and welcome everyone. I'm very pleased to start off our webinar with introducing Dr. Kristin Cummings. So Dr. Kristin Cummings is the Chief of the Occupational Health Branch of the California Department of Public Health. Prior to joining the California Department of Public Health, she served as an Epidemic Intelligence Service Officer, Medical Officer, and branch chief in the Respiratory Health Division of the National Institute for Occupational Safety and Health under the Centers for Disease Control and Prevention. She's a board-certified internal medicine and occupational medicine and is a member of the Standing Committee on Personal Protective Equipment for Workplace Safety and Health of the National Academies of Sciences, Engineering, and Medicine. Her research interests include inhalation exposures and respiratory health of workers, with a particular emphasis on occupational health disparities. So Kristin, whenever you're ready, please feel free to start.
Thank you very much. Let me just pull up my slides. Can you see those? Great. So it's really a pleasure to be here today. Thank you for including me. I'm going to be speaking about what is an epidemic of silicosis among engineered stone fabricators and the experience that we've had in California. Before I get to the graphs and the numbers, I wanted to put some names and faces to the problem that we'll be discussing today. This slide shows 2 former California countertop fabrication workers. who became ill with silicosis in their early 30s. Juan Gonzalez on the left and Gustavo Reyes on the right. Juan and Gustavo were featured in stories about this issue in late 2022. And at the time that these photos were taken, both were awaiting lung transplant. Gustavo later received a transplant and is doing well. Juan unfortunately passed away in the intensive care unit before a donor lung became available, leaving behind a young family. So a little bit of background on silica and silicosis. Silica is also called silicon dioxide. It's a well-known occupational hazard that continues to cause disease. The hazard is from respirable crystalline silica, of which quartz is the most common form. Silica is found in rock and concrete, masonry, and silica sand, and so workers can be exposed when they disrupt solid silica-containing materials like drilling through rock or cutting concrete. And they can also encounter silica during sandblasting, during demolition, and in mining work. And the problem starts with respirable crystalline silica particles, which are very small, as you can see here with the comparison to a grain of salt. They're so small, in fact, that they can reach the deepest part of the lung, the alveoli, where they can cause inflammation and scarring of the lung tissue. And over time, this can lead to respiratory failure and eventually death. So silicosis is one of several health effects of exposure to respirable crystalline silica. And there are three forms that we recognize. Chronic silicosis develops after 10 or more years of exposure at relatively lower concentrations. Accelerated silicosis has the same kind of pathology. The damage to the lung looks the same under the microscope, but it happens more quickly, presumably because the exposures were higher. And then there's a form of silicosis called acute silicosis, which looks different under the microscope. There's a buildup of material called surfactant in the deepest part of the lung. And that can happen even after weeks, just weeks of exposure to what are thought to be the highest concentrations. Silica is toxic to cells from the immune system, macrophages that live in the lung and help us fight infection. And so people who have been exposed to silica are at higher risk for different types of infection, including mycobacterial infections like tuberculosis, as well as fungal infections. Silica is also a recognized carcinogen. It causes lung cancer, and it can cause chronic obstructive pulmonary disease, or COPD. And it's associated with a number of autoimmune diseases and chronic kidney disease. I want to take a moment to mention one of the worst industrial disasters in U.S. history, which occurred during the construction of the Hawks Nest Tunnel in West Virginia in the 1930s. This project was intended to divert water from the New River to a hydroelectric plant downstream. And workers on this project drilled through rock, which was mostly sandstone, to create the tunnel, generating very high silica concentrations. They were in confined spaces with no ventilation or respiratory protection, and many developed disabling respiratory symptoms within a few months, that acute form of the disease. And as many as up to 2,000 workers died as a result of these exposures. I think that demonstrates just how hazardous silica exposures can be to workers. Well, the new risk that we'll be talking about in terms of silicosis is engineered stone. This is a material also called artificial stone or quartz that's used primarily to make kitchen countertops. And it contains especially high levels of silica. So workers who are cutting and grinding engineered stone, who we refer to as stone fabricators, can be exposed to hazardous levels of silica dust and develop silicosis. Engineered stone has been gaining in popularity due to features like its durability and stain resistance. And you can see on this graph that since 2007, demand for engineered stone in the US has increased dramatically. It's now the most popular material for countertops in this country. As you can see here, the issue really comes down to the silica content of engineered stone. It's a much higher content than the natural stones like marble and granite that the engineered stone is meant to replace. So workers who are cutting this material in the same shops, using the same tools, the same environment as they would cut marble or granite, are being exposed to much higher levels of silica just because the material has so much more silica in it. And they're also exposed to resins that are used to bind the silica together, and to pigments that are used to create the colors and patterns, and those may also be toxic. We know that dry cutting of engineered stone is particularly hazardous. Air sampling that has been done in shops and also under experimental conditions has shown that dry cutting generates very high silica exposures. And studies of workers have found that a history of dry cutting is associated with developing disease. Dry cutting can occur in the workshop as the material is being initially prepared and cut, but it can also happen at the residential or commercial site where the countertop is going to be installed as final modifications are made using hand tools. I'm going to jump now to the global epidemic that's happening. With the increasing demand for engineered stone that's occurred worldwide, have come reports of cases of silicosis in countertop fabrication workers. And the first case that was published in the medical literature was in 2010 from Spain, followed by a very important report from Israel in 2012. Since then, many other countries have reported cases. And the first case in the United States actually was reported from Texas in 2015, so we're going on a decade now. And those cases elsewhere prompted our branch at the California Department of Public Health to begin looking for cases in California. An epidemiologist in our group found this first case in 2019 by reviewing hospital discharge records, and she identified a 37-year-old man who'd been hospitalized with silicosis in 2017. And further records revealed that he'd worked in a countertop fabrication shop from 2004 to 2013. And so after nearly 10 years of working in this kind of environment, he presented in 2013 to an emergency room with respiratory symptoms, and he was ultimately given a diagnosis of silicosis. Over the next few years, his symptoms and his lung function worsened. And in early 2018, he was referred for consideration for lung transplant, but he was deemed ineligible. And later that year, at the age of 38, he died of silicosis. That index case led to a workplace investigation that identified 2 additional cases among co-workers, including another fatality. And all of these cases occurred in young Hispanic immigrants in their 30s at the time of diagnosis. And I mentioned that age because typically silicosis from other industries takes longer to develop, and we don't typically see it in people this young. So the fact that they were only in their 30s was remarkable. Chest X-ray screening of the employer's current workforce found 5 additional cases. So the overall prevalence or burden of silicosis in this worker group was 12%. 12% of the current workforce had silicosis. The median age of the cases detected through screening was just 37. Again, that was remarkable. And so since that time, we've continued to monitor the situation in California. We receive reports from physicians and from healthcare systems throughout the state. And this slide shows the number of engineered stone-related silicosis cases we've identified through those surveillance activities by the year identified. And you can see that the numbers have increased greatly in the past few years, and that total for 2024 is not yet final. We expect it to continue to increase a bit as we review additional reports. Well, we're now at a total of 230 cases statewide. These cases are occurring in relatively young men, as I've stated, often in their 30s and 40s, and almost all are immigrants from Latin America. Many are under or uninsured. We are aware of at least 14 deaths from silicosis among these workers, and at least 27 lung transplants have happened, which is a very intensive intervention for a preventable disease. And those deaths and lung transplants really reflect the severity of disease that we're seeing in association with engineered stone. As you can see in the figure, most cases have been reported from Los Angeles, followed by other areas of Southern California and the Bay Area, which are really our population centers. I should mention that this is not just a problem in California. Cases have been reported from other states across the country, but most states don't have a system to track silicosis cases. So it's very likely silicosis is occurring anywhere that engineered stone is used to make countertops, even if the disease has not yet been recognized or reported to public health authorities. And in fact, we think the cases that we know about are really the tip of an iceberg. And we have been working to enumerate the industry in the state and determine how many shops there are. So far, we've identified more than 800 shops in California. You can see on the right is a heat map of shop locations with hotspots in Los Angeles, Orange County, San Diego, and the Bay Area. So together, these shops likely employ thousands of people, and we think nationally the workforce is probably on the order of 100,000 workers. And if you apply that prevalence of 12% that we got at that one California workplace, or if you use the figures that they have found in Australia using more sensitive screening modalities, more than 20%, we're talking about hundreds or thousands of additional unidentified cases in our state and nationally in this industry. So I'll spend a few minutes on talking about how we can prevent this terrible disease. This slide shows what's called the hierarchy of controls that we use in occupational health. It basically categorizes the potential ways to control a workplace hazard from the most effective at the top to the least effective at the bottom. And to date, control of silica exposures in this industry has focused on those controls that are towards the bottom, lower on the hierarchy. Things like engineering controls. We encourage employers to use wet methods and to use ventilation to try to reduce the dust exposures. There are also administrative controls that can be used. Access can be restricted to areas where exposures are anticipated so that fewer workers are exposed. And then personal protective equipment. And the main piece here is respirators. You can see these workers in this photo are wearing half mask respirators, which are really the last line of defense because it puts a burden on the worker and of course is uncomfortable and can be difficult to wear. Another opportunity to reduce exposures and disease is substitution. Engineered stone is not an essential item for life. Designers and customers can select products with lower or no silica content, and these might include natural products like marble and granite, as well as wood, manufactured materials like ceramic, porcelain, and concrete. And there are newer low silica engineered stone products that are coming onto the market. These products may not be without risk, and we're still learning about the newest engineered stone products and what their impact might be on worker health. But all of these are likely to pose a lower risk to workers than the currently available high silica engineered stone that's responsible for so many cases of silicosis. Finally, elimination is considered the most effective control in the hierarchy. And Australia provides an excellent example of how elimination can be achieved through policy and legislation. The Australians are, I would say, about 5 years ahead of us on the epidemic curve, and they've spent several years documenting very high prevalence of silicosis in their countertop industry. They've made changes to strengthen their silica regulation, but they still struggle to adequately control exposures to silica when engineered stone is cut and polished. It's just a very difficult exposure to control. On the recommendations of a national dust disease task force, the Australian government elected to ban engineered stone as of this past July. So moving forward, companies will not be allowed to manufacture, supply, process, or install engineered stone in Australia. So in summary, silicosis from engineered stone is a large and growing problem globally. It's a disease impacting a young immigrant workforce, And we think that the cases that we know about are likely a vast underestimate of how many people will ultimately be affected by this problem. There are multiple ways to prevent silicosis related to engineered stone, and one very important one is substitution, choosing alternative products that pose a lower risk to workers who fabricate countertops. And I'll end just by acknowledging the many people who have collaborated on this work. Thank you.
Thank you so much for sharing your work and the work of the California Department of Public Health with us. We're going to save questions for the very end of all of the presentations, so all of our moderators and panelists can join in on the conversation together. So we're going to go ahead and get started with our next presentation. It is our pleasure to welcome Michael Wilson, PhD, MPH, and Senior Industrial Hygienist with California OSHA. Since serving as a firefighter and paramedic and president of Local 1270 of the International Association of Firefighters in the 1990s, Dr. Wilson has dedicated his professional career to protecting the safety and health of workers. While serving as director of the Labor Occupational Health Program at UC Berkeley, Dr. Wilson built a coalition of United Steelworkers and environmental justice groups in the Bay Area following a disastrous refinery fire at the Richmond Chevron refinery. His subsequent report to the governor's office led to his appointment as chief scientist for the Department of Industrial Relations, a post from which he drafted and negotiated the state's groundbreaking 2017 Process Safety Management Standard for the state's petroleum refineries. Since returning to Cal OSHA in 2020, Dr. Wilson has served as the senior safety engineer for statewide rulemaking in the areas of firefighter respiratory protection during wildland and urban interface operations, refinery process safety, silicosis prevention in engineered stone and in general industry, and permissible exposure limits for carcinogens, first aid for general industry and construction workplaces. Thank you so much for joining us today. We're looking forward to hearing about the work of Cal OSHA.
Great. Thanks very much, Michelle. And I'm really happy to join Kristin, my close colleague at the Occupational Health Branch. Okay, so are you able to see that okay?
Yes, we are. Thank you.
Great. Okay, so I'm going to be talking about Cal OSHA's emergency silica standard. And this has been in place for 2023, and next week we are bringing this forward for consideration by the Occupational Safety and Health Standards Board for consideration as a permanent rule in California. So this is the scene artificial stone showcase that we're all familiar with. This is from IKEA, and this is the workplace from which those materials are produced. Thanks to Dr. Jane Fazio at UCLA for these photographs. Some of the operations that we're particularly concerned about are dry grinding to create a bullnose edge. A lot of dust produced in that operation, dry edging, and dry polishing. As Dr. Cummings noted, we've been seeing a rapid growth in cases of silicosis in California, and now up to 94 as of this month for October, or for November. Based on the 2019 findings of a special emphasis program that Cal OSHA ran in this industry, and the silicosis rate of workers in this industry that runs somewhere between 12% and 21%, and the silicosis fatality rate of 19% in the industry, we've looked at sort of disease projections and made some rough estimates for that are for about 4,000 workers in California, where we found that about 25% of them were exposed over the permissible limit, permissible exposure limit of 50 micrograms per cubic meter, which is a dangerous level of exposure. And basically taking those numbers and applying them to our current workforce, what we anticipate is that between 500 and 800 of these 4,000 workers could develop silicosis based on the exposure conditions we're seeing and the prevalence rate. And that between 95 and 150 of these workers with silicosis could die of pulmonary fibrosis and respiratory failure absent a lung transplant. And of course, disease is multifactorial, and these are rough estimates, but this is sort of getting a rough estimate on sort of where we're headed under the existing set of requirements in the industry. So this year, after putting in place an emergency regulation in the end of 2023, Cal OSHA has been out conducting silica inspections. And just to sort of, here's what we're seeing. We of the 82, 53 of those inspections have been closed. 29 or 35% of those investigations are still ongoing. 94% of those inspections were closed with violations of the emergency temporary standard. And 27% of the shops were issued an order prohibiting use, or an OPU, where the compliance officer found substantial safety and health problems related to exposure to silica, respirable crystalline silica, and closed the operation of that shop on the spot. These findings are consistent with our 2019 special emphasis program in terms of the numbers of violations that we're seeing in the field. I want to touch on some of the hazards of artificial stone that, as Dr. Cummings pointed out, make it particularly hazardous for workers. This was a study in 2023 by Hoy et al., where 74% of workers exposed to artificial stone at more than 50% of work time, where dry processing was common. 117, 29% of those were diagnosed with confirmed silicosis. The median exposure duration was 12 years. Most of these cases did not experience coughing or shortness of breath. And so a robust medical surveillance program is therefore key to be able to detect early signs of disease. In 2020, Wu et al. Published findings from 18 patients who had been working with artificial stone and had silicosis. Their median exposure duration was 6 years. 22% experienced a rapid deterioration in 6 to 12 months. 40% required lung transplant. 28% died. They compared these patients against 63 others with natural stone-associated silicosis. The median exposure duration was 30 years. 3% required lung transplant, and there were no deaths. This, of course, points to sort of the unique hazards associated with artificial stone. In 2020, a study by Leon Jimenez looked at 106 workers with confirmed silicosis resulting from exposure to artificial stone dust. They were all removed from exposure, but subsequently 33% developed simple pneumoconiosis that advanced to progressive massive fibrosis over a mean of only 4 years. Compared to granite workers and former coal miners, where 10% advanced to progressive massive fibrosis over a mean of 22 years. 2 more of these in 2023. What Ramkissoon reported was the release of hazardous VOCs during cutting, grinding, polishing, and other tasks during fabrication of artificial stone products. Phthalic anhydride, styrene, benzene, and ethylbenzene, and toluene were released during these tasks, and that the phthalic anhydride made up somewhere between 26 and 85% of the total VOC content. And the phthalic anhydride and styrene are respiratory irritants, and the others are carcinogens. So these are VOCs that are released from the resins in the binding agents, when you subject them to cutting and grinding and polishing. So finally, also from Ramkissoon in 2022, one of the things we've been particularly concerned about has been the mass of dust that consists of respirable crystalline silica. As Dr. Cummings pointed out, these are particles that are able to enter the deep lung. And compared to natural stone, what Ramkissoon reported was that natural stone contains 40 to 30% of the mass. So basically the particle diameter is higher in natural stone and less able to access the deep lung. 90% of dust particles in both natural and artificial stone ranged from 0.19 to 0.83 micrometers, so they penetrate the deep lung. But artificial stone particles showed sharp edges, spikes, and fractures compared to natural stone. So they were more likely to cause cell damage, leading to lung tissue damage. And this is just an electron micrograph of showing engineered stone images in the top compared to natural stone at the bottom. And the point of the authors was to illustrate some of just the morphology of these particles that induces cell lysis and the scarring in the lung. As Dr. Cummings pointed out, in 2017, Australia began screening artificial stone workers for silicosis, and their findings that were reported in the National Dust Disease Task Force found that nearly 1 in 4 engineered stone workers who have been in the industry since before 2018 are suffering from silicosis or other silica-related, dust-related diseases, and that the existing frameworks have not effectively protected people working with engineered stone. At the time, artificial stone made up 55% of the market there, and in 2024, they prohibited it in 2023, effective in July of this year. Federal OSHA has also launched a special emphasis program, and they've performed 204 programmed inspections and 42 unprogrammed inspections. They found 68 overexposures to RCS and have issued over 1,000 citations at 149 inspections and violations primarily with the failure to use water to suppress dust. So in December of last year, the Occupational Safety and Health Standards Board issued new protections for stone fabrication workers in an emergency temporary standard, and I'll just touch on those. The way that it breaks down is that if in a stone fabrication shop, if they are using artificial stone that contains more than 0.1% silica, or they're using any other silica-containing product, including natural stone that contains more than 10% silica, they're required to follow requirements that are associated with what are called high exposure trigger tasks. And these are the emergency temporary standard requirements. All other stone products, they fall under the existing Section 5204 requirements that were in place in 2016 and are similar to federal OSHA's silica standard. The emergency standard closes important loopholes in Section 5204 and requires new protections for workers regardless of the exposure levels measured by the employer or objective data obtained by the employer, which I can describe in more detail if people are interested. Cal-OSHA is also mandated under our emergency standard to quickly issue an order prohibiting use when dry cutting is observed, and may issue an OPU for other conditions without the need to conduct air monitoring. Very different from what we were having to do previously. So the new protections require wet methods without exception. require employers to properly handle all waste materials and clean up all waste materials using specific procedures to avoid dust exposures. Use of compressed air is prohibited, as is dry sweeping. They're prohibited from rotating employees to reduce exposures and from allowing employees or equipment to move through dust. Required to maintain records. All employees are required to be provided with a full-face, tight-fitting, powered air purifying respirator or an equally protective alternative. And the use of full or half-face APRs, or air purifying respirators, is allowed if the employer's sampling data shows exposures are less than the action level, or 25 micrograms per cubic meter every 6 months. The employer is required to ensure training and information is appropriate for the language and literacy of employees, and to train employees on symptoms of silica exposure and on engineering controls, work practices, cleanup procedures, and prohibited tasks. And the employer is required to encourage reporting of symptoms of silica exposure without fear of reprisal. Employers are also required to report employees with confirmed silicosis or lung cancer to Cal OSHA and the State Department of Public Health, as are healthcare providers who are required to report confirmed silicosis cases to Cal OSHA and CDPH. So there's a fairly substantial medical surveillance requirement in the ETS, with employees that receive an initial medical exam and then medical exams every 3 years thereafter. And employees with actual or potential silicosis are removed from work and supported financially by the employer for a period of 6 months. So how does this regulation improve enforcement by Cal OSHA? So when employees are performing a high exposure trigger task, and which means that they're basically doing anything with engineered stone, we can enforce the protections without having to prove silica exposures are over the PEL. And that's different from what we had to do and what other states and federal OSHA are required to do, which is to go into the shop and use instruments to determine whether the employees are overexposed. And if they are, then Cal OSHA can issue a citation and compel abatements to protect those workers. Under the ETS, Cal OSHA compliance officers can basically use their own eyes and see what's going on, and can observe dry cutting and what have you with white dust all over the shop, and issue an OPU without having to do the air sampling. And then Cal OSHA is also able to issue an OPU under other kinds of conditions for violations of respiratory protection and others. One of the things that we're pointing out is that wet methods to suppress dust are generally not sufficient by themselves to protect workers from RCS exposure. And so the ETS requires respiratory protection even when wet methods are in place and properly used. There are some exceptions when sampling data shows that the RCS levels are below the action level. So I just have a couple of videos showing one of the problems with wet methods. These were courtesy of NIOSH. And this is, there we go. So you're basically seeing a water stream that's misdirected away from the blade. This is where not enough water is being applied. And so you can see dry sections of the countertop appearing as this worker is. And then what NIOSH has demonstrated, as well as the Georgia Institute of Technology, is that pretty substantial flooding of the surface of the work surface, essentially, as well as an internal tool stream is the most effective approach. What we're seeing now, and this is my last slide, is that the conditions are pretty poor generally. And this is from Karen Smith, one of our industrial hygienists. I'm averaging about 10 citations per countertop inspection. Other COSHOs, which are the compliance safety and health officers I have talked to, are finding similar results. Even cutting wet, they are still over the permissible exposure limit. By issuing OPUs without sampling, we can stop the exposures immediately. We're also requiring a higher level of protection for those workers once the shops do reopen. So I'd like to stop there and turn it back to you, Michelle, and take any questions later. Thanks very much, everyone.
Thank you very much, Michael. Appreciate the great information there. We'll take questions later. Please use the Q&A box to submit your questions. I'm pleased to introduce Lona Rerick. Lona is an architect and sustainable materials leader at ZGF Architects, where she leads their efforts to define, select, and specify holistically responsible materials that support all 5 impact areas of the AIA Materials Pledge. Lona guides clients, design teams, and contractors through the intricacies of system material selection, products research, and specifications writing. She's also a tireless volunteer advocating and collaborating for market transformation, leading to better materials for all. Currently, Lona serves as a member of the AIA Materials Pledge Working Group and as a 2018 AIA Materials Knowledge Working Group Chair who led the creation of the Materials Pledge. She is also chair of the Mindful Materials Board, a member of the International Living Future Institute Materials Health Technical Advisory Group. She serves on the Health Product Declaration Collaboratives Board and is a founding co-chair of the Portland Materials Transparency Collaborative. Turn the podium over to you. Thank you so much.
Thanks, Mitchell. I'm sorry you had to read that whole bio. I am excited to be here today. I feel like I already learned so much from Kristin and Michael that, I'm bringing a little bit different perspective. We didn't learn about this stuff in architecture school, at least not when I went, which was a while ago now. So I lead sustainable materials efforts for our practice, but also I have my toes in a lot of efforts industry-wide across the US. So I'll talk a little bit from both of those perspectives. See if I can advance slides. All right.
It looks like sorry to interrupt you. It looks like we're seeing your desktop and not the slides.
Oh, let me reshare. Thank you so much
Thank
for
you.
letting me know. I was trying to switch to a point where I was looking at the camera instead of looking to my other screen. So let's try this again. All right. Are you seeing slides now?
Yes, we are. Thank you.
Oh, awesome. Thank you so much for interrupting for that. So as architects, we think a lot about making buildings, designing buildings, making the world a better place for the spaces that we create. We don't always think beyond the building to the materials. We use a lot of materials. We have a kind of unique role in our profession that we take a lot of products that other people make and create new things out of those. And we don't always think about the fact that all of those materials have impacts well outside the buildings that we create. I think as an industry, we're getting better at understanding this holistic impact that we have on the world around us and really starting to factor that into how we choose materials. But it hasn't always been the case. Even the early kind of green building days with LEED green building rating systems, if you know what that is, we were talking a lot about the human health impacts of the occupants, of our clients, of the people that were paying our bills. And we weren't thinking enough about the responsibility and the impacts well outside the walls of our buildings. So I had the pleasure in 2018 of leading a group of experts on different aspects of sustainable building materials, and we created what we call the AIA Materials Pledge. And what we were trying to do with the Materials Pledge is really to think about where are all the areas where we have impact, what are the categories of impact that building materials have throughout the creation of those materials, the use of those materials, the ultimate disposal of those materials. And we came up with these 5 impact categories, knowing that there is no perfect building material. If there was one, and some come closer than others, that perfect building material would support human health, climate health, social health and equity, and ecosystem health in a circular economy. That really all of those kinds of impact categories are a way that we should think about things when we start to get to the more holistic impacts of the building materials, the products that we're using to create our designs. The Materials Pledge now has over 300 design firms that have committed to the pledge and committed to the idea of the pledge. Just this year, we started doing reporting on the pledge. How are you doing as a firm to really understand and attack these different issues around building materials? How are you doing on your projects? So that reporting will continue annually from now on. So we're just ramping up to do it again in 2025. So the idea of the Materials Pledge is it's a set of aspirational statements. What we're trying to get to is understanding, like, we can't work towards the goal if we don't know what the goal is. So what are we working towards in each of these impact categories? Supporting human health by preferring products that support and foster life throughout their entire cycles. And I'm not going to read every one of these statements right now, but I encourage you, if you're interested, to go check it out. If you Google AIA Materials Pledge, you'll get right to all of this information. So this is a slide that was inspired by a friend, Kathleen Hetrick at Borough Hapold. It really resonated with me to get my head around thinking about the impact throughout a product's entire life cycle. I can place family members in each of these spots. I won't do that today, but it's just a good way of starting to get my head in the game of the fact that products have impacts throughout their entire life cycle. So 40% of US citizens are in fence-line communities. That means they're near high-risk chemical facilities. Those are mainly marginalized and often BIPOC communities that are affected by the production. A lot of those high-risk chemical facilities are things that are going directly into creating building materials. Within the factories where we create materials, and I've put, countertop fabrication in this category too, the air quality is much less than even what a LEED building would allow. So OSHA, the legal limit of exposure is not healthy according to some of the green building rating systems that we use for our clients. And also we spend a lot of times indoors, and the inside of our buildings is often more hazardous than the outside of our buildings. And last, we are seeing at the end of life of buildings, especially with increasing natural disasters, forest fires, and of course, just regular urban fires, that firefighters are seeing a lot of the impacts of the materials that we're putting in our buildings, that they have much higher cancer rates than they used to have, and that can be tied a lot to the building's materials and what's ending up in the air that they get exposed to when they fight fires. So, trying to bring that down, I always feel like I'm trying to translate from my design and construction friends. Well, what does that mean for how we should approach checking, choosing building materials. I think, the number one thing is to really start putting your head and heart in the game of understanding that these building products have worker impacts, that there are people creating materials, there are people installing materials, there are people all along the supply chain of materials. So you can start to look at, safety practices of those companies. You can look at how they treat their workers. Another thing that we can do proactively is just to avoid known chemicals of concern, or in this case, avoid known materials of particular concern. And of course, preferring local and reclaimed materials, things that aren't so far away, can help us to not hide potential social justice impacts far, far away. So at CGF, we've tried to make this more understandable and accessible for folks by giving some criteria for what does it mean to have a better material in each of the 5 Materials Pledge impact categories. Today, of course, we're just mostly talking about the social justice impact, but we do have product certifications and disclosures that are common in the marketplace that we're pointing to as some indication of a better material. From the social health and equity side, there are a couple certifications out there, the Just Label and B Corporation, that start to get at how the company runs itself and a little bit about how they treat their employees. Cradle to Cradle certification dives a little deeper in all 5 Materials Pledge impact areas. I would say that they are one of the only certifications that really looks at the manufacturing process as part of how they look at a building product, or they don't just do building products, they do all kinds of products. We also like the resource from a nonprofit called Habitable, formerly called the Healthy Building Network. And I'll be diving into that a little bit more next couple of slides. There's a LEED social equity credit that mostly looks at modern slavery and human rights issues in the supply chain. And Design for Freedom is kind of a new player in the game. It's a nonprofit looking at modern slavery and forced labor in the building product supply chain. So we are very aware, even though we did not get educated on this in architecture school, that silicosis is a problem and that it directly ties to something that we have been specifying and using in our projects all the time. And this is, really hard to understand and hard to swallow, but obviously requires action. So these are a couple of the articles that got sent around our office in the last year and a half about this issue, as we kind of struggle with oh no, what are we going to do with this? So I'm going to talk a little bit more about that. Building Green is a resource that doesn't take money from building product manufacturers. So they are a pretty trusted resource on sustainable design in the building industry. And of course, the LA Times article really brought a face and some names to the issue that is happening in California. I always want to think about things more holistically and think about a responsibility more broadly. And I think, Michael got at this a little bit too. Engineered stone is not the only place where we're seeing silica. Obviously, it's the place where you see generally the highest quantity of silica by weight. But there are lots of other materials. And I think that, we don't want to make some regrettable substitutions or act like all these other materials that also often naturally contain silica should be just let off the hook. So I think part of the struggle that we've had within ZGF about how to address this is, if we're addressing it for engineered stone, should be addressing it for other common building materials. We're not going to stop using concrete. I go to a lot of project sites where there's a lot of dust. So it's not just an issue of engineered stone. So it's something that I think that we have a responsibility to think about beyond just, the countertop issue at hand. So as we started to struggle with this, we were looking around at what's happening with OSHA, not really putting a stake in the ground out there and saying you shall do certain kinds of safety measures, even the kind of lower part of the pyramid where you've already shown, maybe doesn't work as well as we want it to. That in this case, we may have to do some things with how we deliver projects that starts to address the issue. We can't depend on government to completely step in and solve the problem for us. And we have a responsibility now that we have this knowledge to understand how to address the issues, and that the issues are not just in the quartz engineered stone countertops, they're beyond that. So we found this resource about working safely with silica and actually added some new language to our countertop specifications that instructs the contractor or the sub who may be creating countertops for the project to start to look at, what is your silica dust control plan? And as a submittal, that they submit that plan to us. I also have been encouraging our project teams, no matter what the countertop material is, to engage with the local fabrication shop and really understand, where is this material being made? Go visit it. Hopefully it doesn't look like some of those pictures that Michael showed earlier. And really that, because of this increased risk of silicosis from these materials, but now that we know, we can't unknow, that we need to take bigger action than we normally would on the kind of means and methods of fabrication of a building material. So I'm going to go fairly quickly through the next few things, but I think, if you're a designer construction professional, I encourage you to go check out some of these resources. So Habitable Informed has this great kind of hazard stoplight spectrum. They don't, it's not an endorsement of any products. It's actually looking at product types. Interestingly enough, when this first came up, quartz is still up here in the yellow category. And so I was hitting up my friends that our leaders over at Habitable. I'm just like, why isn't quartz down in red with the silica issues? And this starts to get at the complication and the potential for regrettable substitutions, that there is no perfect countertop material. There's no perfect building material. And so there's a lot of things that we need to look at as we choose materials. Building Green, again, did a great story just this year on silica and countertops and gave their own recommendations, did encourage architects and designers to stop using engineered stone and quartz, but also encourage them to stop using those plastic materials, acrylic and polyester, solid surface materials, kind of your corians, which is a common substitution for quartz if you're not using that. So just looking at those issues and kind of pros and cons a little bit more deeply, that kind of plastic resin solid surface, yeah, it's a silica-free alternative to quartz countertops. It's pretty durable. It gives you that kind of beautiful monolithic look, but it could have a lot of bad ecological, climate, health, and social justice impacts from the mostly virgin petrochemical plastics that are used to make up that material. And generally, plastics are not really circular. At best, they can be downcycled into a new composite material, but they're generally headed to the landfill after they get used in a building. There are some other materials emerging on the marketplace. I would say that in a lot of ways, we don't have as much data on these materials, but generally, they're silica free, so that's a plus. They're pretty durable and stain resistant. They don't have those petrochemical ingredients. They generally don't require synthetic binders or sealers. So feeling like this, this is a pretty good alternative for the projects that can afford it. They are pretty energy intensive to manufacture, but these are some of these products that we're seeing emerge on the marketplace as an alternative to the quartz or engineered stone countertops that we had been using so much of. Solid natural stone is something that we never completely stopped using, but I would say, there are pros and cons to that as well. There are some stones that have a lot less quartz content or silica content, but those ones tend to be less durable. So we get again into the issue of we want to make sure that we understand how those are safely fabricated before they come out to our projects. They do have the advantage of not using petrochemical ingredients, as a natural product, but there could be other issues with the products. There could be especially for globally sourced stone, there could be forced labor in their supply chain. There could be adverse ecological impacts from quarries. I think in general, when we can and when the project can afford it, and when it's right for the project type, I feel like there's so many caveats there, but there's a lot of, different factors that go into how we choose materials. The natural stone is a pretty good alternative to engineered stone. And solid, especially reclaimed wood, is another good alternative. This is one that we do a lot of labs and healthcare projects. We can't use wood on our healthcare projects. It's too porous. But we also do a lot of workplaces and other types of projects where we could. So wood is generally good. It's generally lower carbon. But it could have, some other cons. We really need to pay attention to the supply chain of those materials. And that's it. I'm going to stop and hand it over to the moderators. Thank you.
Thank you, Lona. Thank you for bringing that perspective about what architects can consider and what actions they should be taken. So I'm pleased to introduce our last speaker, which is Kimberly Mickelburough. Kimberly is the director of Chalk Studio, which is a full services architectural practice. She is an architect and educational building specialist with expertise in executive leadership, architectural design, project management, sustainability, and design thinking. Chalk Studio is an award-winning architectural practice renowned for delivering high-quality, innovative, and sustainable architecture projects that have a positive social impact. They believe in solutions that are holistically considered and specialize in education, workplace, residential, and hospitality sectors. Kimberly, go ahead and take it away.
Can everyone see that?
Yes, we can. Thank you.
Oh, great. Excellent. Thank you for the introduction. And I'm really excited to join this panel today. It's really exciting. I used to work in the United States a long time ago, and that's where I met Lona. So thank you for the invitation to participate today. I'm the director of a architectural practice in Australia, and so today I thought I'll just cover off a little bit about silicosis, which I think was really nicely explained earlier. So I won't go too much into that, but also I'll try and focus mostly on where we got to in Australia with the ban and how that came to be. So just a little bit about our practice. So we focus on being a really holistic practice, so very much focused on our clients and being nice people to deal with, really. And we do focus on education, the education sector, housing, particularly social housing, a lot. And we really come at it from trying to craft spaces that are really thoughtful about the users, but also I guess that whole picture like Lona was talking about what materials we're using so that we think about the whole product life cycle of everything we do, from the people who are working on materials, the people who are inhabiting the buildings, so that the building themselves are actually healthy from a material perspective, but also from a mental health perspective a lot of the time. So our buildings a lot, connect to nature really nicely and have really calm environments. So we just try and think about that whole health spectrum. So yes, so silica, I guess, is also known as silicon dioxide. It's a naturally occurring crystalline mineral in quartz stone. So, and when the stone is subjected to mechanical processing, such as cutting, grinding, polishing, the silica dust is created, and the dust is super fine and can penetrate into the lungs, causing irreversible lung damage. The lung disease is referred to as silicosis and causes inflammation and scarring of the lung tissue, and there's often a delay between exposure to the dust and the development of symptoms. While silica also occurs in other products, as we've discussed today, such as natural stone, engineered stone has been found to be disproportionately represented in the silicosis cases. So compared to natural stone, engineered stone has a significant higher crystalline content and creates a much finer dust, and often contains other contaminants as well, like resins, metals, amorphous silica, and pigments that are also carcinogenic and cause issues. The first Australian case of silicosis was reported in 2015, and since then more than 570 cases have been reported and 551 Australian workers have lodged compensation claims. I should say what's really interesting in Australia about that, we do tend to be very, bodies like Work Health and Safety tend to be very strong organisations in Australia and very well represented. And sometimes Australia is referred to as a bit the nanny state. So when things come up that are health issues, they get taken very seriously by the public and the government and are often quickly responded to. And I don't think there's a lot of fear of reprisals from industry about banning these things. I think their health and issues get taken quite seriously. And if there is a serious issue like this, people will really stand up to action. So we noticed that silicosis gained momentum in the media in Australia, with several media outlets regularly reporting on the issue. So, the current affairs programs, ABC News, which is sort of our state broadcaster, started to report on these issues. And when the Australian media gets hold of something, it does tend to garner a lot of momentum. So there was really interesting things. Yeah, just so I think I have the video on the next one. Right. I thought I had a video here, but maybe it's not working. Yeah, so anyway, things like Nine News, our news channels tend to be quite tabloid, quite similar to the British news. So they do run very, I guess, scaremongering campaigns a lot of the time. So it'd be very sensationalized about the impacts to workers. And it really does get a lot of momentum and attention in industry and the general public. So off the back of that too, there's the CFMEU, which is a really, really powerful construction union. And there was obviously cases of Australian workers that were within the CFMEU who did get inflicted with silicosis. So there was a few affected workers who started this campaign that was Stop This Killer Stone, and they lobbied exhaustively in Australia for the ban. I think the CFMEU, well, in some ways they've actually been found to be quite corrupt, but they are a really, really powerful union. Hence, the Australian construction workers tend to be very, very highly paid. Sometimes I would say probably disproportionately so. So it's a very, very powerful union, and they have a lot of sway with government. So the campaign that they started actually won an ACTU award for its effectiveness. And I think it also helped garner a lot of attention about the issues with silicosis. I think too, in the background, what was going on though is also with things like LEED, our system in Australia is called Green Star. I think professionals in the industry were already starting to wake up by this stage that the engineered stone wasn't really a great product in terms of the risks to health. So whilst this was sort of going on, this campaign around wanting to ban the product, I think in industry, a lot of professionals like architecture firms had actually stopped specifying the product by around this time anyway. We had stopped specifying it probably around 2014, I think. It's actually on a lot of architects' websites that they don't use the product. So I would say at this point in time, it was probably more used in the sort of spec home industry where you've sort of got that are not working so much with the architectural industry, that are more working with builders and direct to industry type product. So on the 28th of February in 2023, the Australian Work Health and Safety Ministers, off the back of a lot of this media momentum, asked Safe Work Australia to investigate silicosis and the potential prohibition of the engineered stone. So I think that was a really pretty much an impact statement that they wanted to understand what a potential ban of the product would look like. And I guess that would have just been really about, I think at this point, they've probably already decided that that's the pathway they want to go down. It's more a risk assessment really at that point. So on the 16th of August, 2023, Safe Work Australia submitted their report recommending the prohibition of the product, so a full prohibition. In the 13th of December, 2023, the Australian Work Health Safety Ministers unanimously agreed to ban the use, supply and manufacture of engineered stone from the 1st of July 2024. So it's really just the full ban has just come into effect. And this includes engineered stone benchtops, all panels and slabs containing at least 1% crystalline silica by weight and created by combining natural stone materials with other composites, including resins, water and pigments to form the hardened product. I think the ban was generally celebrated by those in industry. It was a very quiet announcement. It was just the announcement came that the ban had been put in place. I think obviously those who had really pushed for the ban really celebrated it. So those, you know, the construction industry in general, the CFMEU workers, etc. I think the ban was welcomed by professionals, and like I said, I think people by that stage had moved on from specifying the product. It was probably at that stage most commonly used, you know, by your volume home builders who are still putting it in sort of spec home type developments, which is a big industry here. But I think the people who are going to talk loudly about it had probably mostly moved on from it. Interestingly, there was no, the manufacturers of the products were very quiet. No, there wasn't really any, in fact, I don't think there was any backlash about it that we saw. So no manufacturers stood up and sort of, you know, tried to fight the ban or anything. It was just something that just really went down and went away. And like I said, we sort of stopped using the product. I reckon it would have been early in the 2010s. So whilst the links to silicosis weren't commonly reported, I think there was a general industry-wide acceptance that acknowledged that it wasn't great and that there were risks from using this product and that it was bad for the environment. And also I think other trends, because there was that uncertainty around the product, I think trends for other products had emerged anyway in the Australian market. So the things that are really popular in Australia as alternatives, we tend to see a lot of laminate use, so high pressure laminates, or even so a lot of, if we were doing commercial work in schools, things like that, we use a lot of laminate. And it's interesting, when I worked in the United States, I noticed that it wasn't as commonly specified there for those sorts of things, for those sorts of projects as it is in Australia. And I think there's an Australian company called Laminex, which is a really big company. And so I suppose, I guess it's that industry-wide knowledge of their products. It's a supporting a local manufacturer, and they do offer a really good, you know, range of product as well. They've got some really interesting finishes, some really great colors. So I think they really appeal, are really appealing to a lot of architects for those sorts of commercial style projects. Porcelain slabs have really picked up popularity too. So we did notice that the porcelain that we were getting was often, probably wasn't local. I think a lot of it was coming out of Italy. And so it was probably more of a bespoke product and harder to get your hands on, but they had it in you can get it in 3 mil veneer and 10 mil slabs. And it's great in the sense that super durable, stain resistant, heat resistant. So I think a lot of people are starting to specify that because it did satisfy a lot of the concerns around, with other products around durability, stain resistance and things like that. Typically used in residential. It don't tend to, because of the price point, we don't really see it used so much in commercial applications. But I'm noticing, like Lona said, that Caesar Stone have started to release a porcelain range, which sort of, I guess, makes sense and is a natural follow-on for them. Solid surface products are sort of were popular. I don't think they sort of had a bit of a renaissance of late because of the other thing, but I guess being plastic polymer, they're also, I guess, questionable in terms of their use. We have seen products like the ultra compact surfaces gain a bit of momentum and popularity. Natural stone is still really popular in Australia, so it's typically used in residential projects because of the price point again, but I suppose it is a good natural alternative, although we do need again to be mindful that it's still something that gets sanded and does have a silica content. And it's not super stain resistant, which is a bit of a problem. Concrete is very popular as well, but it's again another one that we do consider because whilst concrete bench tops and concrete things like we even have concrete sinks and basins, that type of thing that are quite popular, but concrete floors in Australia are also very popular. And I just think does concern me about, I've walked on many building sites where they're sanding floors and the amount of dust that is being generated is really quite extraordinary. And I do worry about where, in another 5 years, are we going to see that some silicosis? I don't know what the research, it'd be really interesting to look into research about that too, because they take off sort of 10 mil of concrete with a big sander and the dust is extraordinary. So I think that's a one to sort of put on the radar as it's a great material because obviously you're using just a raw material and you're not applying a finish to it, but just that sanding process has got to be somewhat problematic, I think. And like everywhere, and I guess Pacific Northwest, timber is a pretty popular option in Australia as well. We do see a lot of timber used for benchtop options. I think it sort of wasn't as popular a while ago because of the issues with, it's not as durable. But I think with a lot of the improvements of some of the finishes that are available for timber now, it's come back. And also, I think generally people feel like it is a reasonably safe material and a health material. So, and especially now with some of that you can use water-based sealants on timber is really great. And there's less risk of toxicity and things like that in those products. Stainless steel is also a really good alternative that we use. We do, in some cases, we actually will use timber and just overclad the top of the bench or something with stainless steel just to give it that durable element. And you can obviously use a really fine grade stainless steel when you do that. And the only issue with stainless steel, I guess, is it scratches. So it's just, we need to just be mindful that clients are happy with that. And that's it. Thank you.
Thank you, Kimberly. So we'd really like to thank all of our panelists for providing us with such great information and foundational information to understand the health risks linked to engineered stone, interventions underway to protect workers both here in the United States, but also Australia, an overview of the AIA Materials Pledge and its relationship to workers, and then factors to consider when choosing alternative materials. So now I do want to open up the session to questions from our audience. So again, if you have a question, please enter it into the Q&A feature on Zoom. So we do have one question here, and I think this one is probably best for Mike. So they're interested in learning or knowing how the silica standard may apply despite objective data.
That the term objective data is used in the existing federal silica standard, which was adopted by California in 2016, is that it's a way for employers to use sort of industry-wide surveys and modeling data, modeling exposure data, for example, to demonstrate that it's very unlikely that exposures will be over the action level, and exposures to respirable crystalline silica. And we closed that that sort of option for employers in our emergency temporary standard, and you know, really have seen it as an off-ramp to regulatory compliance. And so the regulation requires engineering controls and wet methods and so forth, irrespective of objective data obtained by the employer, and actually also irrespective of air monitoring work conducted by the employer. But I don't know if that was what the question had to do with, if it had to do with the way objective data is used in the regulation, or it was there was some other aspect of that.
I think you covered the question. I think it was more so, how would an employer know whether it would apply if we don't have that objective data? So I think you kind of covered that. So thank you. If we have another question, which I think is for Lona, I see you wanted to answer this question, which was why not manufacture engineered stone without silica? So use other materials with fewer or no health hazards.
Yeah, I accidentally hit the answer live button, but I can take a crack at it anyway, even though I'm not a manufacturer. Manufacturers are actively looking at alternatives. They understand that especially in the US, that these kinds of products were really popular. And there are some good parts of engineered stone. It can take a lot of waste material of stone and create new products out of it, and be potentially, an answer to a circular economy. That can we get to a place where, if the countertop materials that we're taking out of a project aren't, big enough to get reused in a new installation, can we then kind of go down to the next level of reuse and, grind that up and make new materials? So there are manufacturers that are actively looking at what are the products that are going to replace this, because I think they see that the industry is aware, and potentially, the ban in Australia might just be the first of many to come. So.
Yes, thank you, Lona. So kind of piggyback off of that question, this is kind of a question that we all have, which is how can architects, designers, and occupational health professionals work more together effectively to promote safer material choices, such as alternatives to engineered silica stone, in both the design and the construction process? And I think this question is for all of our panelists.
Yeah, I mean, I love seeing the data that Kristin and Michael shared today. I would love to see more of that data for other materials, because I feel like there are other materials where we just don't know that we're creating issues for worker safety. And the more we know, the more we can make informed comparisons. I took a crack in my slides at making, some judgments about different materials and some of the downsides and potential hazards to people along the supply chain that could exist with those materials as well, because there's just no perfect material. But I think there are definitely materials that are better. And so the more information that we have, the more that we can start to take, definitive action to make better selections, and to even start to specify safety in our specifications. I did have one question that came up in the Q&A that I answered just via texting back, that was about can you specify in the contracts? Generally, architects have had this approach that the contractor is in charge of means and methods, and we're just saying, this is what it needs to look like. This is how it needs to be put together. I think, that we have to take a bigger responsibility and start to dip our toes a little bit into means and methods and ask for that kind of worker safety piece as well. And so that was what we did with our specification, to add something about like a silica safety plan. But Kim got at this too. Silica is an issue throughout lots of building products. So where are the next places that we should be asking for more and asking for better worker safety?
Thank you, Lona. I see, Mike, you have your hand raised.
Yeah, it's a great question. And I really appreciated Lona's description of the AIA Materials Pledge. I think it really covers a lot of ground. And, there is this fundamental problem in the US that there is no requirement of product manufacturers or chemical formulators, chemical manufacturers to release or to demonstrate data on the health and environmental effects of their chemicals or products before they put them on the market. And there's no minimum data set, if you will, that's required. And so one thing that could be helpful, I mean, and I think the AIA Materials Pledge is a really great platform that sort of gives people access to all of these various tools that are kind of trying to solve that problem. That we don't have a basic data set requirement in the US. And like, the Healthy Building Network, now that Habitable Informed has done great work on that. But it does seem to me that architects and designers could be asking for a minimum data set having to do with products and materials that are used, that will be, specified or used in the design of structures, and which has the effect of driving information into the market, and then also calling for, in public policy and legislation, requirements so that you as architects can make informed decisions about the materials that are being used, and that requires legislation. So just a couple thoughts there.
Thank you, Mike. Kristin?
Thanks. In thinking about how we can work more effectively together, I have to highlight that just bringing us together in this forum has been really important. In my day-to-day activities, I don't interact with a lot of architects, so that's probably true for Mike as well. So I think I really appreciate the organizers who have brought us together to think across disciplines in this way. In terms of the question of other materials, like Mike said, I really appreciated Lona's description of these aren't easy decisions. There are a lot of factors that go into deciding which materials to use, and none of these are necessarily without hazard. But I will say that as we have conducted more and more surveillance trying to get at the issue of the burden of silicosis in California, we're not just finding cases of silicosis related to engineered stone. We're finding cases that are likely from other industries, things like construction and mining and foundries. And those workers tend to be older. They tend to be not as sick as Mike was describing in that Chinese study comparing engineered stone silicosis to other types of silicosis. So I do agree that we have to think more broadly about protecting workers across the spectrum. But I also don't want to lose the message that engineered stone and the epidemic that we're seeing is really unique, and this is a uniquely hazardous product that should be a focus in terms of deciding how to approach things. And I think the ban in Australia is an excellent example of how you can eliminate the problem by eliminating this particularly hazardous material.
Yes, thank you, Kristin. Thank you to all our panelists again and to our audience for their questions. I do want to turn it over to Michelle to wrap up our webinar. I feel like the time flew, but it's close to the end of our time together.
Yes, thank you so much to all of our panelists. Oh my gosh, I could listen to everyone answer tons and tons of questions for at least another hour, but we will be sensitive to people's time. So thank you so much again for joining us today. It was wonderful to hear from all of you. Just a reminder that in the chat, I'm going to post our post-course evaluation. So we invite you to please provide us with your feedback. Providing education to architects and designers is something that was new for us, and so we really are interested in what topics you're most interested in. So the post-course evaluation is in the chat. Once you submit your evaluation feedback, you'll be redirected to a second survey where you can provide your name and email address where you'd like your certificate. If you're a member of IDCAC, you can provide us with your unique identification number in lieu of a certificate. And again, thank you so much to our panelists today. I learned so much, and thank you to our co-moderators and everyone who joined us to watch the presentation. We appreciate you all being here.